Good morning. I'm Dr. Najibin Fatima. Today's topic is photoconductive cell. Let us restart. So we will be discussing about the types, introduction, construction, characteristics, and working of the photoconductive cell. So you can see transducers which can convert the light energy into electrical energy. These are called the photoelectric transducers. There are different types of photoelectrical transducers like photoemissive cells, photoconductive cells, photovoltaic cell, and photojunction. Today I am taking photoconductive cell. So in a photoconductive cell, the two terminal semiconductor devices are using whose terminal resistance will vary with respect to the intensity of the light. So come to the photoconductive cells. Actually, these cells are the elements whose conductivity is a function of incident electromagnetic radiation. So the conductivity of the certain substance material increases when they are exposed to the radiation or light is called photoconductive effect. Conductivity of certain substances or material increases when they are exposed to the radiation or light. This is called photoconductive effect. So the material which are using for this photoconductive cell are first one is silicon, germanium, cadmium sulfide, and cadmium selenide. So these are the materials using for the photoconductive effect. Now, the electrical conduction in semiconductor material occur when free charge carriers, example electrons, are available in the material and when electric field is applied. And when light falls on the photoconductive material, it releases electrons, which increases flow of current produced by an applied voltage. So when light falls on the photoconducting material, it releases electrons, which increases flow of current produced by an applied voltage. So the current increases with the increase in the light intensity with applied voltage. If the applied voltage remains constant, the current will be increases with the increase in the light intensity. It means actually the resistance of the semiconductor decreases with the increase in the light intensity. Therefore, the semiconductors are called the photoconductive cells or photoresistors, and these are also called light dependent resistors, LDR. So most commonly used material is cadmium sulfide with the energy band gap of 2.42 electron volt, and cadmium selenide with the energy band gap of 1.74 electron volt. Silicon is having energy band gap of 1.12 and germanium is having energy band gap of 0.66 electron volt. So on account of large energy bands, both materials, cadmium sulfide and cadmium selenide, both of these material gives a very high value of resistivity at ambient temperature. So photoconductive cells are made by sintering the required powder of cadmium sulfide or cadmium selenide into the tablets of required shape and enclose them in a protective envelope or glass or plastic. The electrodes are deposited on the tablet surface. Construction is somewhat like this. So the cadmium sulfide or cadmium selenide uh, are shaped into tablets, and the two electrodes are deposited. So this is one electrode, this is another electrode. The positive and negative potential can be given across these electrodes. So let this be positive and let it be negative. Positive, negative potential. The battery positive terminal is connected and battery negative terminal is connected here. So this is a photoconductive cell. The spectral response of cadmium sulfide and cadmium selenide are shown here. Spectral response. This is drawn here. On x-axis, wavelength is taken. This wavelength is in nanometer. On y-axis, the relative response or current is taken. Current is taken here. This is 0, let this be 300, 500, 700, and so on. So these two are the spectral response. Graph number 1, graph number 2. One is representing cadmium sulfide and second graph is representing spectral response of cadmium selenide. So no response to the radiation of a wavelength shorter than the 300 nanometer. That is, if the light is having the wavelength less than 300 nanometer, this photoconductive cell will not react if the material is cadmium sulfide or cadmium selenide. So you can see there will be no response if the light having a wavelength less than 300 nanometer. If this light which is having wavelength less than 300 nanometer, if it falls on the photoconductive cell of cadmium sulfide or cadmium selenide material, there will be no response. There will be no output at this photoconductive cell. So there will be no response other than the visible light. So from this diagram, we can see the cadmium sulfide photoconductive cell has a peak response at approximately 350, approximately 350, 400 nanometer wavelength light. And when we talk about the cadmium selenide photoconductive cell, so we can say we are getting peak of approximately 550, approximately 550, 600, between 550 and 600. So the cadmium sulfide gives the highest response at 400 nanometer, approximately 400 nanometer, and the cadmium selenide giving the maximum response at approximately uh, at approximately more than 500 nanometer. So maximum response of cadmium selenide comes at 615 nanometer. Now the photoconductor has a very high resistance at a very low illumination level, which is of mega ohm. The resistance drops to a few kilo ohm when it is exposed to the light. So when light falls on the photoconductive cell, this converts this light energy into current or voltage. So in this manner, the photoconductive cell is acting as a transducer, which doing the conversion of light energy into electrical energy. So this much about the photoconductive cell. Thank you.